Alright, so now we're going over ionic radius. So first of all, we have to know what an ion is. So an ion is an atom with a charge because they've lost or gained electrons. So you can have an ion with a positive charge if it loses electrons, and a negative charge if it gains electrons. So remember, electrons are negative, so if you lose them, the atom becomes more positive. If you gain electrons, they become more negative. So why do atoms gain or lose electrons? Well, because they want to be stable. What does it mean to be stable? It means if they follow the octet rule. So they have 8 valence electrons in the outermost energy level, the valence energy level, or if they have 2 electrons at the first energy level, like helium. So S2P6, or for helium, S2. Okay, so 8 valence electrons. So they're all trying to get to this octet rule, the noble gases. So let's take a look at metallic ions. So if we look at sodium, sodium is 1s2, 2s2, 2p6, and I believe 3s1. Okay, so what can it do to become stable? Remember, it wants to have an S2P6, right? So it can actually lose this. If it loses this, or it loses this S1 electron, it'll now become 1s2, 2s2, and 2p6, which it wants. This is stable, right? Because in the second energy level, you have 8 electrons. Another way of thinking about this is sodium's Lewis structure looks like this. Okay, it either needs 8 valence electrons, but it can actually get rid of this 1 valence electron. So if it gets rid of this, it becomes Na plus 1. This electron corresponds to that. All right, boron. If we write out boron, 1s2, 2s1, 2p1, I believe. Sorry, this should be 2. All right, so what could it do? It could actually add 5 more electrons, right, to get to 2s2, 2p6. However, it's not going to do that because it's actually easier to get rid of these 3 electrons. So boron has 3 electrons like this, valence electrons. It can actually get rid of these 3. To get rid of these 3, now it's stuck with 1s2, which is a full valence shell. And so it'll be boron if it loses those 3 electrons plus 3. What we basically want you to see is that if anything in group 1, so anything in group 1 has 1 valence electron, anything in group 2 has 2 valence, anything in group 3 has 3 valence. What it's going to do is all in these groups, it's going to lose electrons. So this will be x plus 1, this will be x plus 2, this will be x plus 3. It's going to lose these electrons. So all metals tend to lose their electrons to become more stable. Okay, so metallic ions, they tend to lose electrons when they form bonds. They form positive ions, which are called cations. And then their radius is smaller than the atoms. And why is that the case? They lose an entire energy level. The strength of the nucleus increases, and this pulls the charge cloud in tighter. So let me just give you examples. Here we have sodium. So sodium, its Bohr model looks like this, right? And so what it's doing is it's getting rid of its 1 electron, right? And so that's that. So you can kind of see, now let me write it in though. So this is Na, and Na plus 1 is a removal of the electron. So now you have 11 protons, and instead of 2, instead of 1 electron or the third energy level, you have now 2 energy levels, so it gets smaller. So anytime you have a positive charge, you have a smaller radius. So positive charge equals a smaller radius. Okay. Now you can kind of think, what about nonmetallic ions? So let's think about chlorine. Chlorine is 1s2, 2s2, 2p. Chlorine is going to be, 2p5. So since chlorine is 2p5, it's not 2p5, 2p6, 3s2, 3p5. Chlorine is 3p5. It's super close to the s2p6. It just needs one more electron, right? So it's going to add that electron. So it'll be 1s2, 2s2, 2p6, 3s2, 3p6. So it's adding one more electron. So we'll say chlorine -1. It's its most stable. Why? Because now it has a full energy level. And so in this case, chlorine actually will get bigger because it adds an extra electron, which kind of minimizes the nuclear positive charge. Oxygen is 1s2, 2s2, 2p4. So what I want you to see, it's closer to 2s2, 2p6, right? That would be its most stable form. So it's going to add 2 electrons. So it's going to be 1s2, 2s2, 2p4. So in that case, it wants to add 2 more electrons. It'll be O-2. So metallic ions. So for example, so chlorine, you can see, it might be easier to look at it this way. It just needs one more electron. Oxygen in group 6 needs only 2 more electrons, and so you can add them here. By adding them, you're going to become more negative. And then, so nonmetal ions, they tend to gain electrons when forming bonds. They form negative ions, which are called anions, and then the radius becomes larger. And then why? They have extra electrons that weakens the pull of the positive nucleus. So those are nonmetal ions. So let's just get our example of oxygen. So here you have oxygen. Oxygen has 8 protons. So then that's neutral oxygen. If you add 2 more electrons, now you have 8 electrons out here, which you want. However, now since you have more negative charges and positive charges, what happens is the charge of the protons kind of decreases relative to the charge of each electron. And so it kind of allows the electron cloud to relax or get a little bigger.